The population of a town grows at a rate of R of t is equal to 300 times e to the 0.3 t people per year, where t is time in years. At time t is equal to 2, the town's population is 1,200 people. What is the town's population at t is equal to 7? Which expression can we use to solve the problem? So they don't want us to actually answer the question. They just want us to set up the expression using some symbols from calculus. So why don't you pause this video and try to think about it. So let's just remind us what they've given us. They've given us the rate function right over here. And so if you want to find a change in population from one time to another time, what you could do is you could take the integral of the rate function from the starting time, t is equal to 2 years, to t is equal to 7 years. So we're going to take the integral of the rate function, and what this is going to tell us, the change in population from time 2 to time 7. So this is, we could say, let me just write this. This is the change. I'll use delta for change, or let me just write it out. Change in population. Change in population. Population. But they don't want us to know, they're not asking us for the change in population. They want us to know what is the town's population at t is equal to 7. So what you would want is, you would want what your population is at t equals 2 plus the change in population from 2 to 7 to get you your population at 7. So they tell us the population at time t equals 2, the town's population is 1,200 people. So if you want the population at t is equal to 7, it's going to be 1,200 plus whatever the change in population. If you take the integral of the rate function, and this is the rate of population, this integral is going to give you the change in population from time t equals 2 to t equals 7. So we can see clearly that is choice D right over here. These other choices, we could look at them really quick. Choice B is just the change in population. Assuming that this is actually increasing. So this would tell us how much did the population increase from t equals 2 to t equals 7. So that's not what we want. We want what the actual population is. This is how much the population increases from time 0 to time 7. Now you might say, well, wouldn't that be the town's population? Well, that would be the town's population if they had no people at time 0, but you can't assume that. Maybe the town got settled by 10 people or by 1,000 people or who knows, whatever else. So right over there. And this is taking the derivative of the rate function, which is, it's actually a little hard to think about what is this. This is the rate of change of the rate at time 7 minus the rate of change of the rate at time 2. So I would rule that one out as well. Let's do one more of these. So here we have the depth of water in a tank is changing at a rate of R of t is equal to 0.3 t centimeters per minute, where t is the time in minutes. At time t equals 0, the depth of the water is 35 centimeters. What is the change in the water's depth during the 4th minute? So let's pause the video again and see if you can figure this out again, or figure out what expression can we use to solve the problem. The problem being, what is the change in the water's depth during the 4th minute? All right, so we've just talked about if you're trying to find the change in a value, you could take the integral of the rate function over the appropriate time. So we're talking about during the 4th minute. So we definitely want to take the integral of the rate function. And we just have to think about the bounds. And all of the choices here are taking the integral of the rate function. So really the interesting part is during the 4th minute. So let me just draw a little number line here and we could think about what the 4th minute looks like. Or actually, let me just draw the whole thing. So let's say this is R of t right over there. Or you could say y is equal to R of t. And this is t. And let's see, the first minute goes from 0 to 1, second minute goes from 1 to 2, third minute goes from 2 to 3, fourth minute goes from 3 to 4. The rate function, this actually just looks like a straight up linear rate function, looks something like this. And so what is the 4th minute? Well, the fourth minute is, the first minute is this one, second, third, fourth. The fourth minute is going from minute 3 to minute 4. So it's what we want to do is the expression that gives us this area right over here under the rate curve. Well, this is, our lower bound is going to be 3, and our upper bound is going to be 4. And so there you have it. It is this first choice. You might have been tempted here if you got a little bit confused. Hey, maybe the fourth minute is after we've crossed the t is equal to 4, but no, that would be the fifth minute. This would tell us our change over the first 4 minutes, not just during the fourth minute. And then this is just going to be 0. If you're taking, this is, what is the change in the value from 3 to 3? Well, it didn't change at all in that, because it's essentially at an instant. There's no time that passes from 3 to 3. So you could rule all of these out.